We're going to start a new topic for mixing cohesive solids and free-flowing solids. What are the equipments which are used for mixing cohesive solids and free-flowing solids? First of all, what are cohesive solids? Solids which are having a tendency of sticking to one another. Okay, solids which are having a tendency of sticking to one another are called as cohesive solids. For example, you take impregnation of dye in rubber. Rubber, you know, it sticks. Okay, so how we can impregnate or incorporate the pigment into it and then color it, add some lubricants to it. So all these things require different types of machines, and depending upon the situation, the machines are also changed. For example, we have seen only one single agitated process vessel in which a mixing of two immiscible liquids can take place and dispersion of an organic phase in an inorganic phase can take place, and it can also be used for suspension of a catalyst. It can be used for dispersion of gas in a liquid. It can be used for reaction. The same equipment will have so many functions. But in case of this cohesive solids, we don't have a single equipment. Means what? The machine which is used in a paint industry may not be used in mixing in PVC company, polyvinyl chloride. So like that, depending upon the situations, we design our equipments depending upon the nature, whether they have cohesive solids and free-flowing solids. Free-flowing solids means what, sir? They don't have to stick to one another. They remain inside the system as a single identity till the processing is over. Okay, so this is about the cohesive solids and mixing free-flowing solids. Now let us see the theory part. The mixing of solids, whether free-flowing or cohesive, resembles to some extent the mixing of low viscosity liquids, to a certain extent, because in both the cases the agitator has to induce motion to the material, and inside the material, depending upon the situations, flow currents will be formed. Because of the flow currents, there will be movement will be there. Because of the movement, there will be momentum transfer will be there. Because of the momentum transfer, the entire liquid start moving after some amount of time, which will also enhance mass transfer and heat transfer. So basically, we use an agitator in either of the system to create some motion to the liquid. Babu, kindly mute your phones. Kamesh, kindly mute your phone.
Yes, sir. Yes, sir. Sorry, sir.
Then, both the process intermingle two or more separating compounds to form a more or less uniform product. For example, I said just now, mixing of two miscible liquids, water and methyl alcohol. They are existing as two components, but after mixing is over, it will exist as a uniform solution. That's the meaning of it. That should be our aim. Some of the equipment normally used for blending liquids may on occasion be used to make solids also. So in some cases, when we find that the creation of flow currents are sufficient for generation of motion inside the free flowing solids, we can use the same equipment, no problem. But rarely we find such kind of situation in this subject. Yet there is a significant difference between the two processes. Liquid blending depends on creation of flow currents which transport the unmixed material to the mixing zone adjacent to the impeller. So as I said just now, that the first impeller, when you give a power supply, the agitator will rotate and the impeller start moving in the bulk of the liquid, and the impeller will be pushing the liquids, and when we push the liquid, we create a motion inside the liquid. Because of this motion, flow currents will be formed, and because of the flow currents, the movement will be started in other parts of the liquid within a short span of time, and then we find that the entire contents of the liquid can be mixed properly for a particular purpose. Then, in heavy paste or the masses for particular solid, no such currents are possible and mixing is accomplished by other means. So in case of heavy pastes, it means what? Where the viscosity is very high. How it is possible to create a flow current when the material is not allowing the flow currents to move through it? What is a paste? A paste is a material whose viscosity is very high. Already we have seen that when the viscosity is very high, it is very difficult to create flow currents. So similarly, even if you take a discontinuous solid masses, that is the particulate solids are free flowing solids. In the free flowing solids also, we cannot create flow currents. So what we should do? We should go for other types of the means by which mixing can take place. In consequence, much of the power is normally required in mixing paste and dry solids than in the blending of the liquids. Because in the blending of the liquids, it is a continuous material, flow currents are possible, they move from one part to another part, and hence the mixing will take place successfully. But in case of the paste and dry solids, no such kind of things are possible. So normally what we should do, the power consumption increases because you wanted to mix all the contents which are resistant to flow, and you have to create a flow. So hence the power consumption increases when you go for the paste and dry solids. Apart from that, the paste, if they exhibit a property of adhesiveness, they stick to the material of construction. So we have to scrap it also. So additional work is done to scrap that material and then bring it to the zone of impeller so that it mixes with the other material. Then only it is. Otherwise, what will happen after some time? The entire solid will stick to the walls of the container, and there is no mixing will take place. So even we have to design the agitator in such a manner that it will scrap the material which is sticking to the vessel walls and then bring it to the zone of mixing so that the activity of mixing will be completed. Another difference is that in the blending of liquids, a well mixed product usually means a true homogeneous liquid phase from which random samples, even very small size, all have the same composition. Very good. This is suppose you take mixing of water and ethyl alcohol. So we have charged the reactor with ethyl alcohol. Then we are going to pump water to the deflect, and then we start the mixing. And then what will happen after 5 to 10 minutes, whatever the time is given to you in the batch sheet, you stop the reactor, you stop the agitation, take out the sample, whether it is 1 liter sample, 2 liter sample, 10 ml sample, 30 ml sample, whatever is the size is there, size of the sample. You take from n parts of the container, from different places of the container, you take it and then send it for the analysis. You find that the concentration is same, that is the percentage of methylene and the percentage of water is same. Why? Because it is a liquid and we call it the blend. Okay, so whether it is small size or a bigger size, from wherever you take the sample, it will be showing the same readings. Now, in mixing pastes and powders, the product often consists of 2 or more easily identifiable phases, each of which may contain individual particles of considerable size. For example, take the example of coating tablets by means of a sugar. So what we will do now? We will coat the tablet with the sugar syrup, and then we have to dry it, and then we have to see that they all move. Okay. So one component is easily identified. We can identify where is the colored tablet, where is the other colored tablet. Suppose that the mixing is over, if you see, one tablet is having a color and it has been dried and the other tablet is still existing as it is, then what will happen? That indicates that our activity of mixing is not proper, our design is not correct, we have to do something else. Similarly, you take ointments. We are supposed to mix or disperse the active ingredient called as sulfamycin in quinol base. So the main liquid, the main base will be bigger one. In that we are supposed to see that the sulfamycin ointment is mixed properly in that entire medium. If not, what will happen? First you apply, you get sulfamycin, then you get the carrier. So no such kind of. You have to first mix, and more apart from that, if both the individuals are exhibiting some amount of color, what will happen after the end of the stay? Whatever the mixed color is exhibiting, as we have seen in the first class, it should be maintained, because by colorimetrically also we can say that the product is mixed perfectly, because there are various methods are there which we have already seen to say end of the reaction or end of the mixing. So this is one of the methods. From a well mixed product of this kind, small random samples will differ markedly in the composition. In fact, samples from any given such mixture must be large than certain critical size if the results are to be significant. So in case of the well mixed product, if you take small samples also, what will happen, sir? They will be giving the same readings. But in case of free flowing solids, the sampling is very important. You have to take sample from all parts of the container and then you see that the standard deviation is 0. Then only means what? Already we should theoretically know what should be the percentage of A in B, what is the percentage of B in A, because you only know how much kgs of A you are putting, how many kgs of B you are putting. Ultimately, if you are putting 50% of A and 50% of B, after mixing is over, you take a sample. By theoretically, you should say that the percentage of A in this sample is 50%. Then only it is a mix. Otherwise, it is not a good mix. So, whatever the mixing you do it, the sampling should match the sampling value with the material which we have charged. Then we say mixing activity is perfect, or else we have to change the design. Yeah, I think. A well mixed product is one that does what is required and has necessary property like visual uniformity, high strength, uniform burning rate, or other desired characteristics. Okay, now here also we have to see when we can say the product is well mixed, whether it is cohesive solids, whether it is free flowing solids. We have to mix them properly and release it to the market. So what are the properties which we are what are the parameters which we are looking into, which says that the mixing is complete? The first one is visual uniformity. I said just now that A and B are free flowing solids, or A and B are cohesive solids. So A and B may be imparting some individual colors. One is exhibiting red color, another is exhibiting blue color. Very good. Once you mix it, the mix should have if the mixing is proper, then the material after the mix will have a constant color. And this we are supposed to take it as the specimen sample, or a sample which is 100% showing the reading. So now colorimetrically, if the color decreases, then the strength is decreasing. That indicates that the percentage of the mix is not proper. So first point is what? Visual uniformity. If the materials after the mixing, if you find that there is a uniform mixing is there, then if you say uniformity is there in the by visually, then we can say mixing is proper. Then the second one is high strength. For example, in the cement purpose, you take it. We add mortar, we add sand, we add cement, and then we add water. So nowadays we have all mixers are coming to the picture, tumbling mixers. They mix it and they dump it. So when they dump it, what will happen? If you construct it and if there are no cracks are there, that indicate that yes, you have done the mixing properly, and then it will be able to resist high amount of compressive forces. So before that, what we should do? We should conduct an experiment. What type of experiment we are going to conduct? Yes, you take known quantities of cement, known quantities of mortar, known quantities of water, mix them properly for some amount of time, and then you make artificially a brick. And then you send this brick cured this for 21 days, as you have seen the manufacturing of cement. Whatever you want to do, curing and then drying, you dry. Then afterwards, what you do? You send this sample for compressive strength. And if you find that it is able to resist more amount of forces, then we say, yes, our activity called as mixing is perfect. Whatever the ingredients we have added, we have designed a system to mix them properly so that it can resist a high amount of compressive forces. This is one conclusion. Then we can say this mixer can be used for mixing these three materials. That is what we have to conclude. Then, uniform burning rate. I hope you are studying in chemical technologies, propellers, etc., etc. So there you say the star configuration, circle configurations, etc. It will come after certain amount of time. But before we start this, you can see one point. When we have a Diwali, we have rockets. So some of the rockets will go very well. Some of the rockets will not burn properly. Why? Because the mixing of ingredients should be uniform. If the mixing is uniform, then after we charge that one with this mixed material, and after drying, if you burn the rocket, if it is going uniformly to a larger distance, then we say we have mixed the ingredient properly and then it is successful. Now how the rocket is going? Because of burning. And if it is uniform burning rate, then velocity will be constant. So this is one of the methods by which we can say uniform burning rate. It is not rate, sorry, it is rate, uniform burning rate. Then it is also a conclusion that our mixing equipment for this particular materials is a satisfactory one. So we have to conduct experiment and then determine the properties of the desired product at the end. Then we can establish whether this mixture is suitable for the task or not. If not, change it away. But this is not the true case in the case of liquids, because we have only one type of agitator process itself, where the entire process will be taking place. Then, a good mixture is the one that produces, and other desired characteristics. So it may be exhibiting some other properties depending upon the nature of the material, nature of the product, that we are supposed to check it out. Then, a good mixture is the one that produces this well mixed product. It is at a lowest overall cost. The total cost should be very less. At the same time, the power consumption should be very less. If at all any power consumptions are more than what losses are more, then the remaining part of the energy comes out in the form of heat. So it may damage the material, especially in case of food industry. We cannot assume that loss of energies are there. So the prime aim, as I said yesterday, the prime aim of a designer in designing an instrument should satisfy the following factors. First one is what? The cost should be less. The operating cost should be less. Cost of the equipment should be less. Cost of operating the equipment should be less, and its performance should be very high. These are the basic characteristics which everybody look into that before we purchase any type of equipment. Then, mixing heavy paste and plastic solids and rubber is more an art than a science, because we have to do lot of actions, and because of these actions, mixing will take place properly. I hope in a domestic example, I will give the example of making a parota and a chapati. You know what the difference between both the cases. Making parota is art of your hands. Chapati, of course, anybody can make, whether it is hard or small, that is a different story. So it all depends upon the mixing art, how properly we are mixing it. So basically, mixing of heavy paste, or plastic solids, or free-flowing solids, and rubber, gummy and gooey materials, it is a science. Okay, it is an art of mixing it rather than we call it a science. The property of the material to be mixed vary enormously from one process to another process. Very good. Because I said just now that in which industry we are there, depending upon the nature of the materials. For example, the mixers which are there in the paint industry, we cannot use in the leather industry. The mixers which are there in the leather industry cannot be used in MRF, Madras Rubber Factory. The mixers which are there in ITC Bhadrachalam paperboard, where coagulation of cellulose is very important, that is different. And similarly, mixing of free-flowing solids, that is adding two types of ingredients in a capsule. Okay, a tablet may have two compositions, and if you have a capsule, two different color spherical bars, you find it. So how to mix them so that we can maintain uniformity? You can't employ a human being and say, you take 1 gram of red bars, you take 1 gram of two blue bars, and then put it into the capsule and give it. So you can imagine what will happen. It takes so much amount of days for your production or productivity to take place. So in order to avoid that, machines will be doing this work. How the machines will be doing work? So properly mixing. First, we should mix both the materials depending upon the desired characteristics of the product, and then the tablet making will take place. Then a batch may start. A batch may start as a dry, free-flowing powder, becomes pasty on addition of liquid, stiff and gummy as the reaction proceeds, and perhaps dry, granular, free-flowing once more. So he says that in this sentence, what happens is that before we start the process, what is the physical properties of the materials? A and B. A is a liquid, B is a solid. A is a high viscous liquid, B is a dry powder. A is a solid, fine powder, B is a fine powder. Then after you start mixing them, what will happen to the final product? What is the final state which the customer is demanding? Whether he is demanding a free flow solids or a paste, because if you remember in the manufacturing of ammonium nitrate, we have given different forms to the market. We gave ammonium hydroxide in the form of flakes, we gave ammonium hydroxide in the form of pellets, we gave ammonium hydroxide in the form of the liquid, even the urea also, we gave liquid urea also. So it all depends upon the customer. So depending upon the customer's specifications, we are supposed to manufacture according to this. At the same time, we should also follow what type of state it is attaining during mixing and after mixing. This is also very important. Then, one minute. Yeah. Indeterminate properties of the material such as stiffness, tackiness, wettability are significant in these mixing problems as viscosity and density. See, determinant properties which we can predict and then establish. Indeterminate means what? Whether the properties which are not usual to our laboratories, like stiffness. Stiffness we don't measure in our laboratory, in our conventional laboratory, but it is a procedure how a material is reflecting to a load, applied load, if it is elastic in nature. For example, take a rubber band. Rubber band is elastic material, but there is no stiffness is there. So we should have a property, we should have a material which will be exhibiting a property of stiffness. And then tackiness means what? If you, for example, in your hand you take honey, put your honey in your hands and then try to stretch it. So you find a small layer, isn't it? We call this pakam in Telugu. That is the meaning of tackiness. And wettability, the ability of a material to wet the container. If it is wetting the container, we have to give much importance to scrapping because there may be a loss of batches there. So these are the main things apart from the conventional properties of the materials, that is the viscosity and the density. So if the viscosity is high, it becomes very difficult for us to mix to take place because we cannot create any flow current. Similarly, density means what? The container should be able to have good strength to hold those mass because density says something regarding the mass and the volume. Mixes for paste and plastic masses must above all be versatile. So they should be robust in nature. The constructions are very high because there will be lot of vibrations will be there, and the electrical motor which is giving, it may be making some frequencies or oscillations which should be registered by the foundation boards. This we will see perfectly when we come to our MUO lab, how we have kept the machines on different types of foundations to absorb all the vibrations, so that when we stand in front of it, nothing is there in front of it. Nothing you are going to feel except the sound will be there. So the machines are versatile in nature, robustic in nature. In a given problem, the mixer chosen must handle the material when in its worst conditions and may not be so effective as other designs during the part of the mixing cycle. So the mixer which we are designing in an emergency also, it should be able to do our problem. It should be able to solve our problem. Suddenly, but nowadays we have situations where we can stop the process because of instrumentation process control. One example I will give you. In the manufacturing of cement, we have seen dry process and wet process. Dry process is very dangerous, but involvement of instrumentation process control is very high because it consumes less amount of the water. So hence there mixing of free flowing solids. Okay, so there what will happen, sir? It is in calcium carbide. Sorry, it is in calcium carbide. So mixing of free flowing solids, they involve the machines, and if any problem is there, we can stop the machines. But here we have to design for the worst condition also for some amount of time before it stops the equipment uniformly. Then, types of the mixers. What are the different types of the mixers? Mixers for dry powders include some machines that are being used for heavy paste and some machines that are strict to the free flowing powder. So we have two separate categories: machines which can use for cohesive solids, machines which are used for free flowing solids. There is no interlink either between them. We should use them separately depending upon our material to be mixed. Mixing is by slow speed agitation of the mass with an impeller, or by tumbling, or by centrifugal smearing and impacting. Now, how our mixing is taking place in a agitated process vessel? It is only because of creation of the flow currents. Who is creating flow currents? The impeller will be inducing the motion to the liquid. So inside the liquid, flow currents are born and they start moving, and because of this, mixing is taking place. So in a way, the creation of flow currents is depending on the movement given by the impeller and your orientation of your tank. Whether you have baffles, whether you don't have a baffle, whether it is an off-centered agitator or a side entering propeller, all this matters. But in this case of our mixers for free flowing or cohesive solids, the agitator first point will rotate with a very slow RPM, and then next one is what? The equipment casing itself may be moving. I will show you some examples, don't worry. The casing itself is moving in some cases. Impeller is not moving. Impeller is not moving. For example, hope you have a wet grinder in your house. If you see the wet grinder, the casing itself is moving. So when the casing is moving, we have a different type of action. Similarly, we should have centrifugal smearing action, that is wiping over one another and hitting the material with the high force within a short span of time. It's called as impact. Impact means what? Application of a huge amount of force on a specimen for a shorter duration is called as impact. Smearing means what? Yes, wiping the material over one another is called as smearing action. Centrifugal means what? Away from the center on the walls of the container, it will be smearing it. So this I will show you in my videos, no problem. These mixtures are fairly light in construction and their power consumption per unit material mixed is moderate. So though they are in the previous statement we have seen, it is versatile, means what? It is robust in construction. But at least we should see that the material which you are using, you should try to use that type of material which consumes less amount, density is very less. Because if you make it with the stainless steel or iron, what will happen? Its density is very high. So the amount of energy required to drive the machine itself is increasing. So you try to choose a material which is having lower density, but at the same time it suits to your requirement of mixing of solids. And their power consumption per unit mass of the material is moderate. I don't say high or low, but if it is moderate to us, then we can accept it, because I said that it is very difficult to create any flow currents. In mixing equipment for paints, rubber or heavy plastic masses, the material must be brought to the agitator and the agitator should visit to all parts of the mix. So this is not a valid statement for the mixing of liquids, where our agitator is hung from the top, centrally located, rotating at a constant RPM, which doesn't have any movement. But here it is different. The agitator will be moving its blade at the same time. It may have a planetary motion, because I want the agitator to go to all parts of the container and then mix the material which is not able to come to my zone of mixing. And at the same time, I should scrap the material which is sticking the container. So these are the difficulties which we are going. The action in this machinery is well described as a combination of low speed shear, smearing, wiping, folding, stretching, compression, etc. etc. So these are the means by which we see that the materials will be mixed properly. The mechanical energy is applied by moving parts directly to the mass of the liquid. Anyhow, that is, without that we cannot mix it properly. Now, let us see a first statement: mixers for cohesive solids. some of the most difficult of all the mixing problem. Why? Because once you dump the cohesive solids, they will go to the bottom and they stick to it. Once you start something, they will stick to the walls of the container. So the first point is what? Bringing them to the zone of mixing is a big problem for us. Then you can think of mixing, dispersion, whatever. Some of the most difficult of all the mixing problems in cohesive solids, such as plastics and plastic mass materials and rubber. With cohesive solids, the mixing element cannot generate flow currents. Instead, they can shear, fold, stretch, compress, and the material to. These are the usual methods by which we can do it. So let us see the first equipment which you are supposed to draw in the examination, called as. Now we will concentrate on mixing of cohesive solids first. Then we will concentrate on mixing of free-flowing solids. Let us see mixing of free-flowing cohesive solids. This is the first example of a mixing of phase or cohesive solids. A very simple one: agitator blades, motor, device for raising the agitator, a rotating change can. So you know very well the machine has to rotate and we are supposed to give some power to it. So this is given by means of a electrical motor. So this is the example of a electrical motor which gives the motor force. And this covering is what? A device which is used to transfer the torque from the motor to this machine. So this machine will be having a pulley here, and with the help of a V-belt drive, we can connect this motor's pulley to this. So this is called as driver's pulley and this is called as driven pulley. So driver's pulley is there mounted to this to the electrical motor that will rotate with a high RPM. Now with the help of a belt, V-belt, that is connected to the driven pulley. So here it is there. So now once it starts rotating, in this we can create movement in this entire setup. First step is, what we do is in the system, first you try to rotate this lever in this fashion. If you rotate this lever in this handle in this fashion, what will happen, sir? This agitator, whichever is there, it will try to come up. See, this is the scale on which it moves in the vertical direction. So once you rotate, what will happen? This entire agitator will try to go up. So once it goes up, what will happen? You can see the can which is there on the system. And here remember, the can is rotating. Means what? The motor giving the energy for the rotation of this, at the same time for raising and lowering of the system also. Now what will happen, sir? Here once this goes up, the can is empty, you charge your materials into it, and then what you do, you try to rotate in the reverse direction. When you rotate in the reverse direction, what will happen? The impeller will try to come down. And dear children, the impeller is having rectangular strips which are arranged in different directions on this particular surface. This is a circular surface. I am showing one diagram. This is a circular surface on which these plates, these rectangular plates, are welded to it in a different. So once this can is rotating, what will happen, sir? The material will also start moving. But here what is happening? The plates are not rotating. So the feed or the material to be mixed is forced to go through a solid surface which is not moving. So hence it will try to shear, smear, fold, so many things will happen, and then the mixing will take place. And here we have to continue the process of mixing till we get a clearance from the QCD saying that the sample is mixed properly and it has attained desired characteristics. For that purpose, what you do, some amount of the time, after the some amount of the time, start the machine. Again you rotate the handle so that the impeller or the blades will rise up, take a sample manually, send it to the QCD. If QCD accepts it, then you, what you do, remove the material from the can and then use it for further processing. If not, again you try to process it inside the system by lowering the blades and starting the machine so that the can will again rotate. And during this rotation, what will happen? Since the cohesive solids are sticking to the walls of the container, since container can is moving, even the material will also move, but their movement is obstructed, impeded by the vertically arranged rectangular blades in a different fashion. They are not arranged in a different fashion. Okay, they are arranged in a different direction, so that we create some amount of shearing action inside the system. This is the first example of a change can mixture. Double motion mixture, pony mixture. The name of this is the pony mixture. Now let us see the second. So here what is happening? The can is rotating, the agitator is not rotating. This is the first diagram. Second one. Yeah. This is the example of a beater mixer. Okay. Here you see we have a planetary gear. Here now see the construction is robust, versatile in nature because we are not able to see anything. We have a big setup in which we have all sorts of auxiliary items which are needed for running of this equipment are there. But one thing, planetary gear, beaters, change can, cut. So unfortunately for your batch, you didn't go for a industrial project work. If you have gone to a project work, you would have seen so many equipments. Then it was very easy for us to teach this kind of subjects. But unfortunately, because of this COVID, you did not go, and I don't think that you will have an exposure to industry also in this course, in these given situations. So we have to visualize things, and I have to show so many videos to you to understand what it is exactly. So how to start this is first, we again here, this again, once we take this can is not rotating, this can is not rotating, but this can come from here with the help of a card. It comes out, and then manually I will charge the material to it, and then I will introduce the can into it and then lock it by means of this lever. Now I will start the motor. What will happen? So this impeller, the beaters which are, what are beaters, sir? They are nothing but robotic impellers. Impellers which are constructed in this fashion, which are having bars in between, and then it is having a U shape. I will show it. U shape at the bottom so that it can scrap. Now these blades will be rotating in the clockwise direction. At the same time, the shaft is also rotating, revolving around the container. Remember this, different directions. So hence the name planetary has come into the picture. So here the impeller is going to all parts of the container, and then it scraps the material which is sticking or saying ideally, and then scrap it, mix it in the zone of the mixing, and then goes to the other parts. So what is the first point here? This on this shaft, the beaters will be rotating in the clockwise direction, but at the same time this handle will also move on the different parts of the can. Okay, so this is very important for mixing to take place. In the previous example, the impeller was not rotating, can was rotating, and here the impeller is rotating, not only rotating, it's revolving, it is also having a planetary motion to go around this container in this fashion, and the can is not rotating. So this is the first example of a change can mixture. Okay, so this is what we are supposed to draw it in the examination, and let us see the explanation part of it. Yeah. These devices blend viscous liquids, light paste, as in the food processing or paint manufacturing industries. Small removal can up to 5 to 100 gallons in size holds the material to the bed. We are going to add the materials to the can, and then the process continues. In a pony mixture shown below, the agitator consisting of several vertical blades or fingers held on a rotating head and positioned near the wall of the can. The blades are slightly twisted also. Remember, we are not, as I said just now, that the rectangular strips are not arranged in a fashion, in a different fashion. We twist and turn them so that our aim is to stop the motion of the moving solid, so that we smear it, we cut it, we apply shear forces, and then mixing takes place. Fingers held on a rotating head and positioned near the wall can. The blades are slightly twisted. The agitator is mounted eccentrically. Eccentric means what? If we draw a circle and then we put our pencil at the center of the circle, then we say the pencil and the circle are eccentric in nature. This is the meaning of eccentric nature. If the pencil is not kept at the center, then it is called as eccentric. Okay, eccentric with respect to the axis of the can means what? The shaft, whereas in case of our agitated process vessel, the shaft is coupled to the gearbox and the gearbox is connected to the motor. They all are in a perfect axis. Okay, so hence they are centrically arranged. But here no sir, because of the different actions we are going to go for eccentric mechanisms. The can rests on a turnable driven in direction opposite to that of the agitator. So during the operation, all the liquid and the paste in the can is brought to the blades. Suppose as I said just now, here the can is rotating fast, but what will happen? Well, with respect to the velocity of this one, direction of this is not rotating. So hence there will be a movement will be there inside the material which is present in this can, and that will be impeded by this large blades. Yeah. So during the operation of the liquid or paste can brought to the blades to be mixed. How we are doing, sir? Because the can is rotating. When the mixing is complete, the agitator is raised and lift the blades out of the can. The blades are wiped clean because whatever it is sticking, because mainly we are dealing with corrosive solids. So some amount of the solids will stick even to the blades also. We have to remove them. Otherwise what will happen? This material will go to the next batch and your next batch yield will increase, this batch yield will decrease. No sir. So perfect cleaning. So that is the reason why I said check the cleanliness of the reactor. Means what? The traces of previous batch should not exist in this, in any of the operation. So in a batch sheet, first you will see, check the cleanliness of the reactor, check the bottom one. These are the two important before you start operating on a machine. Yeah, wiped clean. And the can is replaced with another containing the new batch. In the beater mixture shown, the can or the vessel is stationary. Okay, as I said just now here, this is not moving. In this previous case, this is moving, the can is moving. Yeah. The agitator has a planetary motion as it rotates and presses so that it repeatedly visits all parts of the vessel. Beaters are shaped to pass through the closed clearances or the side and the bottom of the mixing vessel so that it can scrap the solids which are sticking to the material of construction, so that the property of mixing or the process of mixing will be successful one. So this is about the change can mixture, the first element which you are supposed to draw in the examination and then explain whatever I have explained here. So the notes is also here. This part of the notes today only I will keep it in the Microsoft Teams, and then you can give it and then read it. So before we go to some other concept, any doubts are there, you can raise and then ask. So Pavani, no doubt?
Sir.
Shall I go to next concept?
Yes, sir.
Okay. Then we have the kneaders, dispersers, masticators. These are exclusively used in rubber industry and then paint industry. It is a very simple one. Okay, this also you are supposed to draw in the examination. Two-arm kneader. I hope you know what is kneading. The chapati dough making machine is called as a kneader. You see Amazon, you have so many kneaders, portable kneaders are available. You can make a dough out of it, which can be used for making bread, chapati, or any purpose you can use it. So this is our main motor. This is called as coupling, this part. This is the shaft. So up to this, the electrical machine is obtained. So from here we should purchase in the market. This is the coupling. So from here, that energy will be transferred to this machine. So what is happening in this machine? There are two blades are there. Blade number one, it is in the form of a sigma blade. I will show you this also, sigma blade. And this will be rotating in clockwise fashion. This will be rotating in anti-clockwise fashion. And this is open to top. So this is the handle. Actually, it is tilted. So what we do is we catch this and then turn it other side of your screen. Go back side. So what will happen? This will rotate and this will start top. Then this will be the one which is visible to it. Manually, you can add the materials to it. You on it. When you on the machine, what will happen? I said these sigma blades will be rotating. One is clockwise and this is anti-clockwise. So these are the sharp edges are there at one point. And then what will happen? You give enough time, the mixing will take place. This is about the two-arm kneader, where we use for exclusively used for rubber industry and in the paint industry. And the blades can be replaced. This one, they are connected to the shaft by means of Allen key. You bring Allen key and then remove the nut. This entire specimen will come out. This will also come out. And depending upon our materials, we can, this is the example of a sigma blade, which is there in this example. Okay. Now this is used for scraping the cake. Okay. This is used for leather. This is a suspension of leather emulsions, sharp edges. So this name is disperser blade, and this is double neighbor one, and this is the sigma blades. So here we have the connectors. From here we align this perfectly in this shaft, and with the help of Allen key we tight it, and then we start the process. Okay. So these are the different blades which can be used for the same purpose. Let me show you one video. So this is the electrical motor, this is the coupling, and this is how we transfer the energy to this. These are the gearboxes. So see, this is the sigma blade. Here it is aligned. And suppose at the end if we have a helical mixer at the bottom, okay, this is called as extruder, mixer extruder. So not only this, but what happens is that when the material falls in, we'll see in the video, when the material falls into this, what will happen? This will be rotating. So what it will do, it will be conveying the material from left hand side to right hand side, and the material will rises here, and from again they are mixed. So like that, a rigorous mixing will be present in it. If this is not there, then it is called as a kneader. Suppose if this is there, it is called a mixer extruder. See, this is a sharp corner, and visible thickness is increasing. So they will be doing the mixing action. And this is the panel box. See, now we have started the extruder also. So now you see, this is rotating. In the previous example, this was not rotating. So you have started even the extruder also. The material will be moving in this fashion. They go, they raise it, and again they come. So mixing is taking place like this. See, this is also rotating. And back. Now it is reversing, reverse direction. Again. This is the panel.